Hi, good evening, everyone. So, shall we start or will we wait for another 5 minutes to let people join?
Let's wait for 5 minutes.
Okay, sir.
Yeah, wait for 2 minutes and then we'll start.
Okay, sir. Please close. Close. Start.
Thanks for joining. Let's wait for 2 more minutes. Yeah, 1 more minute. Let others to join. Okay, great. So we'll start now. Let's, yeah, Shruti, you can go
Yes,
ahead.
sir. Yes. Hi, good evening, everyone. For those who are joining us, thank you for joining us. Welcome to today's webinar topic, Failure Mode Effect Analysis and Condition Monitoring. I'm Shruti, Customer Success Manager at Spectransys, and I will be your host. And here is my team and our instruct speaker, Mr. Kotia Naik sir, and our team, Mr. Ashok, Navya, Satvika, and Balakrishna. So first, I'm pleased to share with you about the Spectransys. Spectransys is a technology-driven company specializing in two key areas: education with a focus on training and certification, reliability digital solution that includes remote diagnostic solutions and consulting services. Our mission is empowering core professional. You see here, CORE is the new acronym, that is condition monitoring and reliability engineering. I hope you will all will be proud of using this core word in your career. I just want to brief you about who we are and what we do. We are specialized in offering training and consulting services in condition monitoring and reliability. Our principal association is with the Industrial Press and Mobius Institute. These are the two leading companies in providing the best learning solution. As a part of our learning solution, we provide training and certification in the top core categories. Condition monitoring, which includes vibration analysis, ultrasound, thermography. Asset reliability, a growth path for advocate to leaders. Maintenance management, These are the courses: root cause analysis, dynamic balancing, shaft alignment, oil and weight particle analysis, non-destructive technologies, and some of the mechanical design courses. Some of the most popular certification courses are Vibration Analysis Category 2, Reliability Advocate course, Ultrasound Analysis Category 1. And some are our on-demand skill-up courses are Dynamic Balancing course, Condition Monitoring Engineering course, Root Cause Analysis. On a brief note, what you can expect from Spectransys: accelerated learning, which we provide training and certification courses and some of our skill-up courses. Interaction and mentorship. Our instructors will be always there to help you for the mentorship whenever you get doubts or anything. And hands-on practice. We do have some of our equipments which we will show while the session going on. As a part of our commitment to elevate your career, we built an application that connects aspirants and employers. This ecosystem is a gateway to career success and talent pool. By facilitating this connection, we create a win-win scenario for both the parties. We enable individuals to find the right opportunities and employers to the right talent pool. You can have individual account for both aspirants and employees, which is free of cost. This application features include learnings, book your trainings, are all upcoming courses will be scheduled on this. Events, as you can see that today webinar is already on the website, and many more upcoming events are also there. And blogs. So when you come across in your career some of the case studies which you want to share with everyone, you can write us your case study. Our team will be evaluating it and posting it on our website. Opportunities. So this application, we want to create a network in organization as well as helpful for the individuals. So where you can post your jobs, and for organization where they can do job postings, and individuals can apply for the job and organization will be selecting their profile. And we do have books and some of the courses available with the prices. You can directly purchase from there. View profile, hiring, and this is all to create the networking in this niche field. I would like to suggest you who did not explore this application, you can explore it right after this webinar and create an account if you don't have. You can reach us by email, over the phone, and you can visit our head office. So next, the upcoming course, we do have condition monitoring engineering course, which is going to be conducted on Friday, 29th November. So those who are interested, you can email us at the learn@spectransys.com, or you can contact us at 7331122195. So this course will covers the based on the condition based maintenance program, and it will help you in the reliability improvement, condition monitoring, root cause failure analysis, which is going to be the best approach to minimize maintenance cost and improve machine reliability. And we do have a special offer. Please reach out if you are interested. Thank you. Thank you for joining us today, for taking this time from your busy schedule. So let's invite our speaker today, Mr. Kotia Naik sir, who has 20 plus years of experience in this field, and he is a director of our company. Over to you, sir. Thank you. Thank you, everyone.
Thank you, Shruti. Thanks so much. Hi guys, good afternoon. I hope you are able to see me through camera. Yeah, good afternoon, good evening, those who are joining from the different parts of the world. Thank you so much for joining this webinar for today's discussion on failure mode effects analysis and condition monitoring. Okay, I see that a lot of guys are still joining, and thanks for taking time to join this webinar. Let's go into the detail. So, those who are meeting first time, so this is myself, Kotia Nayak, Director and Lead Instructor at Spectransys. I have over 20 years of experience in condition monitoring and reliability. So, and I'm the first instructor of Mobius Institute in India who started the Mobius Institute training in India and trained over 500 aspirants in India. And I had an opportunity to work with the companies like SPM, SKF, and Mobius Institute. And it was a great honor to work these companies and pleasure to meet all of you in some time. Thank you so much for joining for today's discussion. Let's go ahead.
Sir, are you sharing your screen? Sorry for the interruption. So we are unable to see your screen.
Oh, okay, okay. Yeah.
Yeah, great, sir. Yeah, we are able to see now.
Okay. Thank you. Thank you, Ashok. Sorry, guys. So I forgot to share the screen. So this happens sometimes. Okay. So thank you again. And I'll reintroduce myself again. It's great. It's great again to reintroduce you. Yeah. So today's webinar about the failure mode effects and in condition monitoring. So we'll discuss about that. And we just already started with the topic. Okay, this is myself, Koki, and I was 20 years of experience in condition monitoring and reliability. And as I told you, I had an opportunity to work with the SPM, SKF, and Mobius Institute. So yeah, thank you. It's great to meet you all here for the today's discussion. Let's go. Yeah, for today's webinar, the topics are here: introduction, FMEA, FMECA. These two words are interchangeably used. So we'll discuss about what is FMEA and FMECA and about the condition monitoring. So I hope you know you are all from the lot of members are from the condition monitoring background. I see that those who are joining. So you must be familiar with the condition monitoring. So we'll discuss about the just about one or two slides about the condition monitoring and how do we integrate FMEA with the condition monitoring. So what is the benefit and what are the steps and how we can leverage this integrating FMEA with the condition monitoring and how it can be benefited and about the the key takeaways. So these are the topics we are going to discuss today, and please feel free to ask questions, make it more interactive, and there will be some questions also we'll be asking you to make you more interactions and then also to make you some thought process behind the our discussions. So please feel free to ask the questions, and my team is also present here, and they'll also poll the question on the screen. You can also the answer through your through your mobile devices. Okay, let's get started. Let's understand about condition monitoring and FMEA. Introduction to FMEA and condition monitoring. So these two activities we have been using, and also in these areas we are working. Some of the reliability engineers are going through a process of FMEA or FMECA. FMECA it is also called sometimes. And those who are condition monitoring engineers working with the different technologies, talking about vibration, ultrasound thermography, or any of these condition monitoring techniques. But many a time we have seen these two activities being performed in an isolated way. Okay, So reliability engineers does their, the FMEA process and identifying the asset criticality ranking and the failure modes and all. And condition monitoring engineers are behind, predicting the fault conditions and mitigating the fault conditions and so on. Okay. Let's discover, how the FMEA and condition monitoring together can elevate your equipment reliability strategy. That's the today's discussion. So if we integrate this part, FMEA into condition monitoring, how does it can help? Okay, and how it can elevate your equipment reliability strategy. So let's go into the details. So understanding the FMEA and the condition monitoring in detail and integrating them. Okay, so before we get started, so I just wanted to understand, I see that a lot of reliability engineers and also the condition monitoring engineers here. So I just want to understand from you, what is your, the opinion? What is the primary objective of FMEA? So you can answer this question through your, the comment section, or my team, can also pull the question on the screen. Ashok, can you do that? Yeah, it's already there on the screen. So what is the primary objective of FMEA? Why do we perform the FMEA? Okay, so you can answer through the comments or you can answer through the, direct polling here. Okay, so I can also submit my response, keeping that, FMEA objective is identify and prioritize the potential failure modes. Let's see how all you are, responding to this. Okay.
Most of them have responded option B, sir.
Okay, great. So yeah, as you see that, the rightly said, the FMEA is basically identifying and prioritizing the potential failure modes. Let's go into the details. Okay. So that is the primary objective. Let's go through the, the FMEA in detail, what is it, and then how we do that. So what is the process or the structured approach we take? So FMEA, failure mode and effects analysis. What is it? FMEA is a structured approach to identifying the potential failure modes in a system, process, or an asset, and evaluating the effects of those failures. It's a structured approach in identifying the failure modes and also evaluating the effects of those failures. Okay, what is the purpose of this approach? Is basically the purpose of the approach is predict and mitigate the failure risk before they occur. Okay, so when do we perform this basically? So on a regular, where we are performing the maintenance activities and the maintenance engineers or the condition monitoring engineers, who does this basically, activity following the structured approach, identifying the potential failure modes in the equipments and making a strategic planning for mitigating those failure modes. Who does this basically? Okay, so usually it is being done by the RCM engineer or the reliability engineers, and they come up with a strategy that what type of the maintenance actions to be followed, whether I should go for the preventive, predictive, proactive approach. So they decides then that under the predictive maintenance and there are certain activities to be followed, then it has been assigned with a different task doing the condition monitoring on different equipments with a using a different techniques. This is how the process it comes into that at the end, saying that hey, for this is the asset and these are the failure modes and these are the mitigation strategy for those failure modes. This is how it comes through that. Okay, so FMEA is mostly followed on the systems and processes. Okay, not on the rotating equipments. Okay, so let's go into the detail of what is the activity or what is the structured approach being followed for the rotating equipment or assets which are in industrial facility, what they follow. Let's go through that. It's called, the FMECA. It's also called FMECA, failure modes, effects, and criticality analysis. Okay, FME is more followed on the processes and systems, and then FMECA is more close to an rotating equipment in an industrial facility. So it's more applicable here. What is the element which is being added here to the the FMEA to FMECA? Here it is the criticality, which is an extension of FMEA that includes the quantitative assessment of failure mode and criticality. Okay, so FMECA has built upon FMEA, adding a layer of criticality analysis for system and asset where failures have severe consequences. Okay, so what do you mean basically here? So you will be calculating, what is the risk associated with, if the equipment fails. Okay, what is the consequences of failure? The risk association, how it is being calculated basically, there is a process called RPN. Okay, risk priority number. Okay, so we calculate the risk priority number of each assets, and then based on the score what you are going to get the risk priority number, then we will evaluate that, how severe that failure mode and what is the consequences of that failure. Based on that, we'll follow our maintenance actions. That's where the FMECA comes into that. It is more to an, the for an rotating equipment or for an assets which is being in the industrial facility. Here, the purpose is to prioritize the risk based on the severity, occurrence, and detectability of those potential failures and implement the corrective actions to mitigate those failures. So here we'll be calculating the, as I mentioned, so we'll be calculating called RPN, the risk priority number. Okay, so how do we calculate the risk priority number? The risk priority number is a product of severity, occurrence, and detection. Okay, so then how do you decide the severity and occurrence and detection? How do we decide that? So there's a structured approach, as I mentioned. So we'll go through that. First, we'll identify an asset. First, we identify a system and its function, then asset, and then component two, understanding their failure modes and their severity, occurrence, and detection. So when it comes to the the RPN calculation, basically we look at that what is the severity of the failure and what is the occurrence of the failure and what is the detectability of the failure. Okay, when we say that the severity is low, occurrence is repeatedly happening, that failure, and detection is has an low visibility for detections, or you say that the detectability is very low, then you would say that you may have to look at that, having a kind of a preventive maintenance strategy or something. The severity is high, occurrence is high, detectability is low, then we have to have the different strategy. So the combination of these, when you decide the asset and how they fails, and then severity and rate of occurrence it is going to happen, and what is the chances of detecting those faults, based on that you would prioritize your mitigation strategy. Okay, consider prioritizing the process based on the understanding of the risk. So criticality is added on top of that. So that criticality in terms of the severity, occurrence, and detectability. Okay, where it fits, FMEA in action, where it fits actually. So how it is to be, as a framework, how it is to be followed. So we can consider FMEA is, or FMECA is a subset of RCM, the reliability centered maintenance, and it is also mostly, in the design stage, which is being used as a tool for understanding the failure modes and the risk which possesses it, and the control measures. What is the corrective actions can be taken to mitigate those fault conditions. So this is how the FMEA comes into an action, and in most of these situations, it is being design phase, it is being used, and with that, we come to and say that for this equipment, these are the the technologies, or the condition monitoring activities to be performed, and these are the maintenance actions to be performed. So like that, we come to the planning that, so this is how it should follow. Okay. So now I say that, one equipment we have, say example, it is connected with the owner system, motor which is connected with the gearbox example here. So how do we start with that? First, we understand the system function. Then we come to an, the asset, then asset, which is, the motor and the gearbox, and then gearbox, we go to an each component level, gears, bearings, and, and coming to the motor, we go into the details of the bearings, shafts, wheels, and, these the rotor, stator, and all will go to in component level. So for identifying the my stator fault conditions or, the stator failures, so what are the ways, it can be identified? So that's where, your condition monitoring, the activities comes into that, okay, for this system or for this asset, need to follow the, vibration, oil analysis, motor current signature analysis on the motor, and all other, the vibration techniques to be followed. So we come to a conclusion with that. So, and then in terms of the severity, the severity is high, then, our actions would be like continuous monitoring or maybe periodic monitoring, we decide that. So all this comes through your, FMEA process. First we identify the asset, their criticality and their, failure modes. And based on that, we plan the corrective actions, what are the activities to be followed for that. So in a brief, just to understand our image, you can look at that FMEA is basically an component level, and RCM, as we mentioned, it is an, subset. FMEA is a subset of RCM. So RCM is for a system, how it is to be, what the system function it is, and whether it is the system meeting its requirement or not, function meeting its function or not. Based on that, what are the failure or, things can go, and then FMEA can go into the details of the component wise. Okay, so we can apply FMEA at the system, subsystem, assembly, and the component level. So if you look at the total asset management in that framework, where does the FMEA sits is basically, so the FMEA is as part of the RCM, reliability centered maintenance, where you identify the what type of maintenance strategy it is going to fit, identify the failure modes and their criticality. Based on that, you come up with the what type of maintenance actions to be planned for those. That's how you come up with that. Okay, which is good, like we all do, like condition monitoring. So how does it differ? Like what are you bringing to the table? This all, knows, the reliability engineers knows about the FMEA, condition monitoring engineers knows about their, what are the actions or what are the, monitoring activities they have to be followed. Say, he is responsible performing the vibration and taking oil samples and doing some thermography and doing some, the activities. Yes, this knows everyone. What are you bringing to the table? What are you trying to convey here? Yes, we'll come to the point now. So, what type of assets are typically prioritized in an FMECA? Let's have some question on this. So, what type of assets are typically prioritized in an FMECA or FMEA? Assets with the low repair costs, critical assets that significantly impact operations, assets nearing end to life, or new equipments recently installed. What type of assets are typically prioritized in FMECA? Okay, so here is the question. Yeah, there's some mismatch. Okay, anyway, how FMEA, like how is the RPN is being calculated? So let's say this one. Okay, good. So good response. So we see that the RPN is being calculated on severity, occurrence, and detection. Okay, so good. Okay, yeah, here is the bonus question. So, what type of assets are typically priced in an FMECA? So, in FMECA, so the assets which are most critical that significantly impact the operations that we consider into the part of your FMEA process. Okay, yeah, the answer is B here. Okay, so then let's go and understand more detail how the FMEA or FMECA process it works. So FME and FMECA process, if you look at it, has been classified, or it has been made into the 12 steps. 12 steps. Okay. So first it starts with the identifying the asset. Okay, and then you go to and the asset to component level to you understand the block diagram of the component, and then identify the component which are prone to failure. That comes in identifying the the failure. So that's the step number one, we can say that. So first you identify the system and then asset and then component level and then component which are prone to failure. That's the step number one. Okay, so there's a total 12 steps which is involved in the understanding the the FMEA framework process. So, but we are just the merged into a 5 steps on a brief summary. So the first is basically identifying the components which are prone to failure and assess their failure modes, the ways they it may fail. Okay, so the failure modes we understand here. Then come to evaluate the effects on overall system. What is the the effect. So failure modes, effects analysis, that is the part of the FMEA. So as you see, first identify the system or asset, and then identify the components and which are prone to failure, then assess the failure modes, the way it may fail, and the the evaluate the effects, the consequences of the failure, we can say that. So what is the effects on an overall system if that equipment is going to fail? Then we assign the the risk priority number, but based on the consequences of the failure, and that is the severity, occurrence, and detectability. So based on that, we assign a risk priority number, RPN. If the RPN score is high, then we can consider that equipment is most critical and their consequences are severe and their detectability is low. Then we say that this is very highly critical equipment. Then we should prioritize our actions to mitigate those failures. So that's where the implement mitigation strategy to reduce those risks. So that's where your mitigation strategy it comes into that. So the FMEA process has break down into 5 steps. First, these. So actually, it is a total of 12 steps. The systematic approach to carry out this process. Okay, and yeah, what is the outcome of an FMEA process? What are the outcome is going to come out of this? If you do the analysis or the approach in a structured way, identifying the asset and then components and their failure modes and their effects, and then assigning the risk priority number, and then based on that, we plan our mitigation strategy. So what are we trying to come around, with that strategy? So what are we going to identify with this, FMEA process basically? Elimination of equipment failures, or identification of areas for condition monitoring implementation, or replacement of old equipment, or reduction in maintenance staff. So what are we going to achieve? So when it comes to the the RPN calculations, as we mentioned, there is the severity, occurrence, and detectability. So how do we assess the severity? Like following the asset criticality ranking. Then occurrence is basically is the probability of occurring of the failure is low or high. And then similarly, the detectability, is there a way of detecting its fault, or there are no ways of detecting its fault? Do you have any technologies which can identify its condition? So that's a detectability. Low detectability. we can say that there is no way of detecting, then the detectability score goes high. And similarly, your occurrence, what is the probability of occurrence that fault again and again? If the probability of occurrence is high, then your score goes high. Then severity, what is the severity of that fault or consequences of the fault that occurs? Then if the severity is high, then it is going to have the high RPM. High RPM means that equipment is more critical. Okay, what we do here, what is the outcome of effective FMEA process? Like I see that this is an answer. Identification of, wow, good. Identification of areas for condition monitoring implementation. Okay, good. Let's go to the topics. Okay, so that is the just to understand about the FMEA and FMECA process. So that's good. So in the industrial facility, normally, this condition monitoring is being performed, correct? So then, why should we do the FMEA? Is that really that process or that approach is required? Yeah. So let's, like, I hope, you are, when you're working in the condition monitoring, when you are doing certain activities, you have been following, like taking data or doing analysis or maybe certain activity which you are performing. So most of the times what we do is basically we do, which has been, given the responsibility, and we really sometimes don't understand why we are doing that. Okay. So if I'm taking, say, if this is the asset, so I'm taking, vibration data, temperature, and then oil samples, and then, thermography, and doing, different activities. Are these all these techniques or all these activities adding value to identifying your fault condition in early stage? Or are we missing something which are not added, or which can give you a more insight about the equipment? Are you really stopped and looked at that context? Usually, like, the even most of the vibration monitoring programs, we had a lot of discussions when we do the trainings with the the peers who come here. So they say that I don't know, why this, the 1600 and 1000 lines have been set. Sorry, 1000 hertz and 1600 lines have been set. I don't know, so I'm just doing my job, just collecting data and just, doing basics analysis. Okay. And if you are really, doing some other monitoring activities, why you are doing? I don't know. They've been doing for the last 1 year, 2 years, or last several years. I'm just following that. And have you tried anytime, adding a new measurement point or new, the settings which we can give you a better understanding or better insights of the data what you are trying to capture? Then so no, we are not allowed to do. And then no, I don't know, how to do it. So these are the questions we used to, listen to them. So, but actually, like, so when you are doing, performing various activities, is that really each activity is adding value? Okay, so that's where your FMEA process can help. When there is an equipment, what are the failure modes, and what is the consequences of those failures? Based on that, maybe some equipments which are failing very repeatedly, and their occurrence is high. Then the periodic monitoring may not help you in that case. You must have the continuous monitoring system. And when you decide the continuous monitoring system, what is the interval of the data you take, and how frequently, like, how frequently you do the alarm, or the analysis, and all these things, it depends. So that is why, when many times, we also suggest that you must do auditing of your program once in a year by an external party, external expert, so that you understand that whether whatever the activities you are doing, it is at par the standard, or those really adding value, to your condition monitoring program. So you must do this assessment once in a year, auditing once in a year, so that it will help you the job which you are doing really, it making a sense or not. Of course, you must be doing, the other activities like, documenting the results and presenting to your management, and what is the valuation you are doing. You must be doing. but you should also thoroughly check that each of your equipments, what are the different data you take? Is it necessary to take all this data? Okay, that's where the FMEA can help you in. Let's understand about condition monitoring. Condition monitoring, what we do basically, many of our those who are the part of the webinar today, so they are from the condition monitoring and reliability backgrounds. So as you see that it's a process of monitoring the health condition of the equipment and understanding the its condition through an real time or periodic data collection to identify the early sign of the failures. Okay. So what are the key steps involved in that? We are all aware of that. Just we collect the data of the vibration, oil sample, temperature, current signature data, and different data we collect, and then try to understand that, do some analysis, and understand the the changes in the data, and do the analysis of waveform spectrum, and look at the the alarms and alerts which are being generated at the which has with respect to the threshold limits which have been set for that equipment, and what are the we come up with them action plans, what needs to be done. So that will help in some proactive maintenance strategies, scheduling the repairs before the failure occurs. This is widely we do that, and in some facilities we do the various activities, especially the multiple technologies being integrated. So and then results are better when you integrate the different technologies. We are all aware of that. What is the benefit of condition monitoring? So the benefit of condition monitoring: early failure detection. Okay, so they prevent unexpected breakdowns and extend the equipment life by monitoring its condition and taking the actions on time. So obviously you can extend the equipment life and address the issues before they escalate, and also it will help you in the cost control, cost savings, reduce your maintenance and downtime cost. So this is the purpose of the the condition monitoring, or benefits of the condition monitoring, you can say. But there are the many other benefits also. So it gives a good morale to the people who's working in the plant, because there are no much of failures, and it will help the reduce the safety incidents, and also some the downtime and all, reducing those, it will help. So there are the many other key benefits also, but just to summarize, these are the main benefits. Okay. Yeah. So there's one question, like there are the different condition monitoring technologies, and now the way of condition monitoring doing is, it's changing, and now with the all IoT and IoT technologies, which is contributing a lot for monitoring the equipments in real time. Okay, so which of the following is not a key element of condition monitoring? Real-time data collection, trend analysis, randomized maintenance actions, threshold based on alarms. So I'm not sure, the right question is being popped up on the screen. No? Okay. No worries. So you can just put it on comments. So which of the following is not part of the condition monitoring? We can say that. So yeah, real-time data collection, yes, it is part of the condition monitoring. Trend analysis, yes, looking at the previous trend and understanding, how today and how was yesterday. So trend analysis, it is part of the condition monitoring. Randomized maintenance actions, okay, and threshold-based alarms. Yes, it helps. The condition monitoring. We set some threshold alarms, and we identify that if that exceeds, we get a warning of that. Yeah, so D is the answer, randomized, sorry, C is the answer, randomized maintenance access is not part of the condition monitoring. Okay, so now we understand FMEA or FMECA, and also about the, the condition monitoring. What if we think of, like integrating FMEA with the condition monitoring? What is the benefit you are going to get? Yes, there's a lot of advantage. We can say that. So FMEA for planning, identify the high risk components to monitor, and with the technologies which is to be identifying the failures, and so that we can mitigate those failures before they occur. So FMEA helps for planning and condition monitoring for execution. So which is monitoring the real time of those equipment conditions. So the equipment which possesses the high risk and taking the data to monitor its condition on real time or periodic monitoring. So these both will go in hand to hand. So that will contribute to an, by this way, holistic data driven approach to and reliability can be achieved. So this is the overall purpose of integrating FMEA with the condition monitoring. So when you performing, when you are say asked to do the condition monitoring, just don't do the, the way it is just being asked to do. Just understand that, why we are doing that. And are there any other better way of doing it? Or do I need to add any other techniques or the activities which can add value or and better understanding of the equipment? So first we understand their failure modes and their criticality analysis. Then you implement the condition monitoring technology which is suitable for that equipment. Not every monitoring or measurement technique is required for every asset. Asset to asset, the condition monitoring techniques which need to be applied is different. And the way you collect the data and also the way you monitor is different asset to asset. Not vibration monitoring suits for every application or every assets. Not your oil analysis is applicable for every asset. So you must first do that. What is this understanding the function, components, failure modes, and their criticality. Based on that, you choose a monitoring technique which is most relevant to that equipment, so that it really adds value to the activity which you are doing. Okay, yeah, that's how the FMEA can be integrated with the condition monitoring. That will give you more the data-driven approach to and your reliability, the holistic approach. We can say that.
Sir, we have a question.
What are, yeah.
Sorry for interrupting. So like we have a question from Guruling Wale, like what is the difference between condition monitoring and total predictive maintenance?
Okay. Yeah, we'll take the questions at the end. I appreciate really. So the predictive maintenance and the condition monitoring. So predictive maintenance is basically, planning your maintenance based on the, predicted, or, the based on its predicted failures, we can say that. So it does, lot of activities. So when it comes to the maintenance, it involves many things, not only just predicting its fault conditions. We have to plan for and the space availability for the maintenance which are planning, and we also have to plan for the manpower. We also have to plan many other activities, so that it's part of your predictive maintenance program. So take the like maintenance based on its the predictions, we can say that that's the predictive maintenance program. Condition monitoring is basically, it's not involved in the the maintenance. It's just the monitoring the condition of the equipment and trying to identify the potential faults or failures in the equipment. Okay, predictive maintenance is involved. So once the condition is being identified, and how do we mitigate that? What is the maintenance plan for that? Say what is the you need to replace, or you need to just overall, or you need to the have the what actions you are going to take, that involves in the your predictive maintenance. Okay, steps to integrating FMEA to condition monitoring. So what are this? Basically, how do we start? So what are the steps? The four major steps it is involved. Like identify the critical assets and failure modes, and then assess the failure effects and severity, and then go into the prioritizing the failure modes, and you are implementing the mitigation strategies. So this is how it can go hand to hand. So it starts with the the identifying the critical assets and failure modes, and assess the failure effects and the severity, assigning the RPN and all, prioritizing the failure mode based on the RPN, and then you implement the technologies here, like implement the mitigation strategy here. So that's how it can be integrated into your, the FMEA to end condition monitoring. Okay, so how do we implement this FMEA and condition monitoring? First, identify critical assets and their failure modes, analyze the failure effects and prioritizing the risk, and develop the condition monitoring strategies based on your FMEA findings, and then continuously refine FMEA with the monitoring feedback. So as I mentioned, you must do once in a year, auditing of your condition monitoring program, whether the activities which you are performing is adding really value, or you are just doing for the sake of doing. So you must do the auditing. If you have not having the competency to do the auditing, so you must call the external expert to do the auditing of your condition monitoring program, so that it can be benefited going forward, and quickly learn and adapt what it is to be added further on, improving your the strategy. So this is how it should be. So starts with the step one, identifying the critical assets and failure modes, and then failure effects and prioritizing the risk, and develop the condition monitoring strategies based on the FMEA findings, and then continuously refine those. It should be the continuous process. So that is why I said that once in a year you must do the auditing, learn, and then quickly adapt those what best can be added or what best can be implemented in a way. Okay, why do we need to integrate FMEA with the condition monitoring? Why it is? So why can't this work in an isolated areas or isolated ways? FMEA does its own, condition monitoring does its own. Why why we need to integrate? Yes, proactive approach. FMEA helps identifying critical failure modes that condition monitoring can track. That gives an the proactive approach. Focused monitoring. So the techniques which we choose really adding a value, and which identify which identifies the most impactable failure modes, which is identified in the FMEA study, and enhance the risk management. Combining the FMEA and condition monitoring allows you to early detections, corrections, and reducing the likelihood of catastrophic failures. So that is the the advantage we will have, and also continuous improvement through our the FMEA learnings. What is the the findings which we can feedback from the monitoring results which we are, and into the future FMEA to refine that process and quickly learn and adapt those techniques which we need to be added further improvement. So we see this is a good synergy between the FMEA and condition monitoring. So we must integrate FMEA process into condition monitoring so that it will be the lot of advantages. Okay, that's on the why we need to do that. What is the key benefit of combining FMEA with the condition monitoring? Okay, so as you mentioned, faster repair times or randomized monitoring, early detection of critical failure modes, or increased spare parts inventory. Why we need to? What is the key benefit of combining FMEA with condition monitoring? Okay, guys, so let's add your response and look at that. So what do you understand? I would say this is early detection of critical failure modes. That's a key benefit of okay. Early detection of critical failure modes. That's a good response. Thank you so much. Let's go into that. Okay, so we are come to an end. What is the key takeaways? The key takeaways are, FMEA helps in identifying and prioritizing failure risk, and condition monitoring helps in identifying, the conditions, or allows for real-time asset health tracking or real-time monitoring of the equipment. They both, goes hand to hand. By this way, the combined, they support a proactive approach to maintenance, enhancing equipment reliability and reducing the downtime. That's the overall we can achieve through integrating the condition monitoring with the FMEA. So that's all. And yeah, this is. If you have any questions, we can discuss around, and I'm happy to answer your questions.
So
And
one question we have from Prashant Puhan is, what is the method to define vibration data collection frequency?
okay, vibration data collection frequency is purely depends on the severity of the fault, the failure modes and their failure, the severity. So whether we do it in once in a month or once in a fortnight or continuous monitoring. So that depends on the criticality of the equipment, and that is the severity and their failure modes. So if it is like example, we say that turbines and turbomachinery, there are some online systems being installed, and we continuously monitor because those are very highly critical equipments. And some of the machines which are normal pump or any other equipment which are, their failure rate is low and also they are not critical, then we say that once in a fortnight or once in a month could be sufficient for identifying their developing fault conditions in those equipments. Then we decide, okay, for this equipment, fortnightly or monthly could be a good schedule. So it purely depends. So that is why FMEA will help you in understanding that what is the criticality and what are the failure modes and what is the criticality, and also with the detectability. Based on that, you will come to an RPM score. With the RPM score, it will identify you that this is very highly critical equipment. You need to have an continuous monitoring for this equipment, and this equipment RPM score is very low, and then you can say that just by following the preventive maintenance or kind of the reactive maintenance could be sufficient for this equipment, because it is not possessing any risk, it is not having any consequences of the failure, it is not going to have any problem. Then you can have very normal way, just normal inspection could be sufficient for, because it's not risk, it's there is no criticality involved in that. So then we can just have a normal inspection or normal maintenance activity on those equipments.
The other question from Ramadan is, what is the frequent time of conducting FMEA and FMECA assessment?
But then what is the?
What is the frequent time of conducting FMEA and FMECA assessment?
Okay, yeah. Yeah, as I mentioned, it would be best, to do an, if it is like a newly, when you are implementing the, or, you are starting a new condition monitoring program, or, you just start with the, FMEA process, and you must do, as per my suggestion, we must do once in a year, auditing. So what are your findings, and, what really, is adding value, or are we missing something or can be added to that? So we must do once in a year, so that review and auditing, so that it will help you in identifying the opportunities for the improving the reliability of the equipments.
And the next question we have is, what is the best method to find out the gear failure?
Gear failures, yeah. So as we see, in part of the condition monitoring, so we do sometimes, the integrated approach. So like integrating the two different technologies will give you an, best complement or best results. So for gearbox and gearbox failures would be, best to have oil analysis, that is your wear particle analysis, and your, the vibration monitoring. Both of these will give an, combination of these two will give you best results. Your wave particle monitoring and your the vibration monitoring.
Next question,
Yes,
when
sir.
to do FM? Yes, sir.
Yeah,
Next
Mr.
question.
Dhawan. Yeah.
Next question from
Please.
Samir Kulkarni. When to do FMEA, during design stage or after installation of system or anytime?
So during the design phase, this must be followed, and what are the failure modes and their effects and criticality, which we must follow during the design stage, and the equipment which are being installed then after that you can follow with the the regular condition monitoring activities. And yeah, during the the design process, or during the um, design process, it must be initiated so that we'll be prepared for that. What type of failure modes are there, and and then and also for future monitoring, what are the activities to be followed that can be drawn out of the your design process, and see that there are failure modes are you know more, and then it's going to cause the more severe failures. Then you must redesign the equipment so that those failure modes or failures can be avoided in those equipment. So it must be taken into an as part of the design, from the design part, from the design stage itself.
Thank you, sir. And the next question is, can FMEA can be introduced in a newly constructed plant as we don't know the critical of each equipment?
Yes, you must do it. If you are not aware of that, you must do that. FMEA, going through the the systems and functions, and going to the asset and criticality, asset to and component level, and how those components can fail, and what is the best way of detecting their fault conditions, and what condition monitoring activities can be implemented, or not just condition monitoring, or what kind of maintenance actions can be implemented for those assets. You must do it. If you are not aware of that, the previously which has been gone through the process or not, you must do it so that
Thank
your activities or monitoring activities and maintenance activity will be more valuable.
thank you, sir. And the next question is, which type of industry is best suitable for condition monitoring technique?
Okay. Yeah, so it depends, like what is the process, or what is the product or you are manufacturing. As we see that there are some industries which has a low benefits, but in some industry which has a more benefits. But it applies for most of the the industries. Wherever you have a rotating equipments, there will be failure modes, and to mitigate those failure, you must have an proactive, or the active condition monitoring programs, where it can identify the failures and plan the action based on your findings. So it mostly, wherever you have a rotating equipments, it is useful. The most useful, when you say that, it is oil and gas is most widely implemented. The reason is you have a more the critical equipments in the oil and gas industry, and also the process is very critical. So there it is most widely used, or implemented, but it applies to every industry. Maybe some industry has a low benefits, maybe pharma, say mostly being done on the batch process or batch productions, where you have time to the one batch of time to another batch of time. You have a more amount of time to do maintenance actions, and that conditions they follow mostly on the the preventive maintenance strategy, and predictive maintenance is they follow on a very low level. But it's a like it's for industry which has continuous process and most critical process, where condition monitoring is going to add more value. It applies to every industry, we can say. Okay, so any questions?
Thank you, sir. Thank you for
Yes.
answering the questions.
Thank you, guys. So thank you so much. And if there are still any guys who want to ask questions, Ashok or Shruti, you can unmute and enable the camera also, if they want to ask question one to one.
So one request which we got is, it would from one of the person, it would be more helpful to share one of the case study with FMEA and condition monitoring strategy.
Okay, sure, we'll do that. And I think the time is limited. We can share in the next webinar. We are going to do the series of webinar, and definitely we come up with an good case study where FMEA, how does it has helped in identifying their failure modes, and what is the condition monitoring has been, or what is the maintenance action activities have been involved, and then how does it has been helped in resulting into a benefits. So we'll share that. We plan to have series of webinars, and please do attend. And as my colleague mentioned, so more on the condition monitoring learnings. So we have scheduled a course that's on 29th November. So more on the condition monitoring technologies and their implementation, and also how do we do the basic audit of the condition monitoring programs also involved in this. So, and how do we implement the different condition monitoring techniques and identify the different fault conditions in the equipment. So we'll be discussing in this condition monitoring engineer course. So this is for beginners and those who are want to start their career in condition monitoring uh, side, and those who want to switch from maintenance to condition monitoring side, those who want to elevate their career to further into the condition monitoring. For all of them, this course is very much useful. So if you are interested, you can join us. We do it in a hybrid mode where you can join in classroom or you can join in online. So, and the course information is available on our website, spectransys.com. I would request you to go through that, and if suits to you or your colleague or your friends, please share with them, and we'll be looking forward to see you in the course. Okay. Great,
Yeah.
guys. So last time, when we had webinar, so we took almost 1.5 hours, close to 1 hour 45 minutes. Now this time we are time cautious, and then this is the weekend. Hope you have learned something, and enjoy yourselves, enjoy your weekend, and see you in the next webinar. And there are a lot of events we are doing, webinars, and also we'll be coming up with the international conference. We'll be happy to host you there, and see you there. And take care, and have a great evening and great weekend.
Yeah.
Thank you so
Thank you so
much.
much for joining. So we'll share this presentation as well
Thank
as
you,
the
sir.
recordings by the end of tomorrow. Yeah. Thank you so much once
And
again for
you
joining.
also receive your participation certificate. And please feel free to share on your social media, on your, within your network, and you will receive a participation certificate. Okay.
Thank you,
Thank you,
sir. And
guys.
thank
Thanks
you,
so much.
everyone, for joining us.
Yeah. See you all.